In this video, I'm going to show you how to make a real paper cannon. And when I say real, I mean it. Start by rolling some paper around a copper pipe, installing a plug, and then making and installing a touch hole. Then just put it on a stand, and this thing is ready for action. Stay tuned. Here's my obligatory disclaimer that this video is meant to entertain and to educate, and to demonstrate a concept, not to provide a tutorial or to encourage you to do the same. Do not attempt anything shown in this video. Also, I'm using the word cannon here, and not another word that I think would be a little bit more inflammatory on the internet. I think you understand what I'm talking about. All of that said, enjoy the video. This project will actually work with regular old printer paper. However, I'm going to be using quality control rejects from a local print shop. They are twice the length of a regular sheet of printer paper, and about the same thickness. And it really just goes to show you that if this can be done with office supplies, there's no amount of regulation that can stop bad people from doing terrible things. So I guess it's good to keep the good guys armed. Anyway, here's the paper I'm going to be using, 8.5 by 22 inches long instead of 11. If I were using standard printer paper, I would simply have to insert a new sheet twice as often. And as a former, I'm using this 8.5 inch section of 1/2 inch copper pipe. I discussed the use of a metal liner in this video, linked above. That's a pretty old video and honestly not my greatest, so don't make fun of me. There you can see how the copper liner lines up with the paper. Now I'm only using glue on the first layer of paper to make sure that the metal liner adheres nicely. The friction between the layers of paper is sufficient for all the other wraps. I cannot stress how important it is that the liner is lined up perfectly straight on the first wrap. Otherwise, the paper will go majorly askew while rolling. And I honestly have a lot of experience with this. I made a lot of these that were not as straight as this one is going to be. Practice makes perfect, I guess. It's honestly incredible that a few layers of paper are able to withstand tens of thousands of PSI. And at this point, I have to give credit where credit is due. I originally found this on the channel Nighthawk and Light, linked here. That video was my childhood, and I never would have dreamed that such a thing was even remotely possible. However, it is, so be sure to check out his video. There you can see the first 2 sheets of paper, and these are the most important. You must make sure that these are wrapped as tightly as possible. Otherwise, the liner is liable to bulge and or crack. Anyway, at this point it's just rinse and repeat. I keep inserting layers of paper and rolling them around the tube. Each additional layer of paper means a little bit more power that the paper can withstand. You can see that that wrap of paper was a little off-center, so I'm just realigning it by pushing it down against the table and making it flat again. This is one advantage of using several sheets of paper as opposed to one long roll. It's easier to correct mistakes. On the channel Nighthawk and Light, Ben used a roll of paper from a local craft shop. That method has its own conveniences. However, once you make a mistake, it kind of just compounds and compounds without any chance for correction. As you can see, I'm using a lot of paper and making this very thick. I want to be able to make this as powerful as I wish and not be limited by the layers of paper. Even so, this doesn't even come close to being a full ream of paper, so it's cheap anyway. This is the last piece. And with that, this barrel is almost done. You can see that I'm just straightening out the sides one last time before securing everything in place. And there you can see how straight I was able to get it just by pushing it against the table several times. You can see that there's the straight edge and the torn edge. This is the straight edge. This was the torn edge. This absorbs the glue really well. This side does okay, but not quite as well. So it's a horse apiece which end you pick. If using regular printer paper, there would be 2 straight edges instead of 1 straight and 1 torn. However, the calendar paper was twice as wide, and so I split it lengthwise. You can see that I'm simply securing the edge with a little bit of tape. You could use glue, but it tends to wrinkle the paper and make it a little less aesthetically pleasing. A little bit later, I'm going to completely wrap the outside with packaging tape. That helps to keep it waterproof and also to keep it clean. And trust me, for the little bit of effort, it's well worth it. Here you can see that even wrapping it as tightly as possible, there's still a little bit of give to it. But trust me, it doesn't matter. The ends become a little bit more rigid once the glue is used to seal them. However, the center obviously remains the same. $22 ounces, so it weighs almost 1.5 pounds. And there you can see how I used the packaging tape to preserve it. This helps to keep it sparkling white, and also when it falls in creek beds or whatever, it stays dry. Here you can see I'm using a little bit of Elmer's glue to seal the ends up and also just to make it a little bit more waterproof. A more waterproof glue could be used, such as a waterproof wood glue or a 2-part epoxy. However, those typically tend to have a slight yellow color to them, so I'm going to be sticking with the white Elmer's glue and touching it up if necessary. I typically err on more glue than necessary and let it soak in between the layers of paper towards the ends. It really just helps to preserve the piece. And it's probably easiest to just treat one side at a time and be able to set the other side down on the counter. Here's one of the older cannons that I used in the previously mentioned video. You can see just how few layers of paper I used, and also that this one is a little bit over 3/4 inches in diameter. I only ever used very small powder charges here, and that's probably why it didn't YouTube. I honestly believe that the metal liner was doing 90% of the grunt work with this one. If I tried to use anything near what I'm going to be using in this one, it would certainly have ended up more like this. This is one that proves that the metal liner is not doing all of the work, as you can see that this one didn't survive. Also, this is only part of it. There used to be a whole other section, and I never found it. It's also worth noting that this was a safety test using 3 times the typical charge. This was done because the intention was to be firing these from the hand, and I would only do so with 1/3 a charge that I knew the barrel could withstand. Here's one that was charged with an equivalent of 180 grains of GOEX and a 370 grain projectile. Needless to say, this one didn't make it. However, as with the other one, this one still had a good section of barrel. On this one, it was attached, so I cut off the part that was good and used it for a different build which would use a much more moderate load. Here that is. And here's a card to the original video on that project. The next thing I need to do is plug one end of the tube. To do that, I'm going to be gluing in a lead plug with 2-part epoxy. So I'm simply mixing up a small pool of 5-minute epoxy from the hardware store. And to make that lead plug, a small section of the same copper pipe is hammered into a piece of soft wood, and then molten lead is cast inside. Once it cools, it frees itself from the mold without having to cut it away. To stop the epoxy from making a royal mess of the currently clean copper liner, I'm inserting a bit of cotton ball to stop it from oozing around. This will be removed later. Next, I simply coat the lead plug in the epoxy and insert it in the hole. This process is honestly really messy, and keeping my hands and the surrounding areas clean takes careful effort. You can see that I'm handling anything with glue with some homemade cardstock tools. This is nice because they're disposable and incredibly cheap to make. And to those of you that have already started typing out your angry comments saying that the glue is not sufficient for these kinds of pressures, rest assured, the glue is only here to create a gas seal. Not only will the plug be further secured with tempered steel, but also it is always going to be fired remotely, so even if the plug were to blow, a safe distance will always be observed. There you can see that after a bit of careful effort, I did manage to make the plug fit inside the hole. And since I already have the glue mixed up, I'm using any excess to nicely seal off the other end of the cannon. There you can see how this looks when we're all done with the glue. The finish is honestly pretty nice. Next, I'm turning a bolt into a touch hole. I'm simply drilling through it lengthwise, and make sure that your drill bit is properly suited for the task. Also, lubricating the drill bit with a little bit of WD-40 helps the drilling go a lot smoother. By the way, don't be a loser like me. Get a vise. Gonna use a rag just to wipe off some of the WD-40. This should probably be washed in detergent to make sure that it's nice and grease-free. That's to make sure that the epoxy forms a strong bond when gluing it in place. So there you can see how a hole has been drilled through it lengthwise, and since I was doing it freehand, you can see that it goes a little bit askew. So how I will install this in the cannon is by drilling through the paper but not through the metal liner. Then I will glue the touch hole in place and drill the rest of the way through. That way I can install the touch hole as tightly as I want to and not have to worry about which way it is clocked. Due to the taper on the end of a drill bit, you cannot drill all the way through the paper and a small little bit is still left behind. To prevent that paper from burning out and creating weakness around the touch hole, I treated those few layers of paper with superglue. Superglue is highly flame retardant even in such intense scenarios. I demonstrated that in this video, which proved that treating a fuse hole with superglue will allow Hummers to spin at a higher rotation because the paper does not burn up. It's an interesting video. And remember when I said not to be a loser and to get a vise? Well, I wish I heeded my own recommendations. So I'm simply using a coat hanger that I modified to have a barb at the end to yank that cotton ball out. So with all the screws and bolts I'm going to be using, you want the drill bit that drills the pilot hole to be a little bit smaller than the crest of the threads. Ideally, the drill bit should be the exact same size or maybe even marginally smaller than the shank. Sometimes this makes it too hard to screw into place, so if that is the case, a larger pilot hole will simply need to be drilled. There you can see the pilot hole drilled for the touch hole. You can see how the superglue is soaking into that layer of paper in the bottom. So again, I'm just using 2-part epoxy to glue all the screws and bolts in place. Using the epoxy gives me peace of mind that these bolts aren't going to walk themselves out, and also that they're going to maintain a nice gas seal. The threads on the touch hole were not very deep, and they didn't really drive into the paper very well. I honestly had a pretty hard time getting it seated as deep as I did. But I did end up getting it 95% of the way there, and I believe that the epoxy is filling in any gaps. I'm simply wiping away any excess with a tissue, and then driving in the screws. I'm using 1 large screw and 2 small screws to do this. I think you understand how this is going to go. There you can see that I actually busted 2 drill bits inside of this thing. I don't want to talk about it. Essentially, once the bit reaches the metal liner, it binds up terribly, and with a smaller drill bit, it's really hard to get it out without cracking it. So there are 2 drill bits lost inside of this thing. It doesn't matter though. You probably also noticed how the back of it is bulged a little bit towards the bottom. That's because for the large screw I didn't drill the touch hole deep enough. And then you can see that I simply dressed it up with a little electrical tape and an inverted aluminum can. The aluminum helps prevent scorch marks from building up on the paper. And then finally, I just built a stand for it, and it doesn't take a genius to realize that this is inspired by the original Nighthawk and Light video. Thank you for being such an inspiration. Be sure to stay tuned for a video in which I fire this thing, and trust me, you won't want to miss it. It's not often that projects exceed my expectations as the content creator. Anyway, if you want your immediate fix, check out this video here. Well, that's all I have for you today. I hope you enjoyed the video. If you did, please give it a like and consider subscribing. I thank you for sticking around to the end, and I'll see you next time. Thanks.